So let's talk about VizOps. In the last video, if you saw that, we talked about Vision AI and how that takes what your eyes see and through a camera converts it into actionable data using machine learning, using Vision AI, vision pipelines. So now we want to dig in and discuss some of the issues that customers face when building Vision AI applications. Why is it so hard? There are 4 big challenges. The first is the build. You'll know AI is a very fast-moving space. So the moment your engineers start to investigate Vision AI applications, they'll find there are many different models they can use. There are different frameworks. There is training that they need to perform. There are new models arriving almost every day. Large language models, vision language models, Hugging Face, SAM3, all terms that you need to understand. Are these relevant for me? Do I need to build my application on these? Which is going to work better for me? Trying to understand, okay, am I using the best components? Is this going to give me the accuracy I need? This is a challenge. Then I need to deploy. I need to deploy my application in the location where it is needed. Now, it may be that through network connectivity, I can deploy it centrally within the cloud, but depending on the application type, very often it needs to be deployed very close to the use case. This means on the edge, right? Can I deploy it in a way that is going to be reliable in an environment that perhaps isn't best suited to running server-style applications, right? It could be on-prem, it could be in the cloud. But then we look at the operations, right? I may have got this working great within my lab environment, but now I need to go and put it out there in the real world. I'm going to face a number of different challenges. These are things such as lighting, seasons, different cameras, if you're deploying a Vision AI application across your organization, these things are all going to be different or change. There's going to be variance between these environments. So operating these environments, you need to avoid what is something we call drift. Drift is where inaccuracy comes into your Vision AI application because it is unable to take account of the differences in the lighting or camera quality, increasing inaccuracy in the data that you get. So what may work well in one environment doesn't work well in another. And that's quite aside from all the operational management you need to perform to ensure that the system is up and running and delivering. And finally, there's scale. As you roll it out, you'll need to take account of the differences in the environment, but then also things such as version control, right? Snapshotting, authentication, access control. All of these things start to become important in just the same way that they are with regular applications you roll out across an organization. That's where VizOps come in. Because Plainsight allows you to create Vision AI pipelines. A Vision AI pipeline is really a connection of the key components within your environment. It all starts with the video. From this camera, we come into what we call a filter. And this filter here is video in. The video in filter accepts the video from the camera or from storage or from multiple different sources, but in this case from a camera, and then processes it to make it ready and available to be processed by the next filter in the chain. Now in this example, we'll say that this is for a quick service restaurant, right? A QSR. Quick service restaurant is interested in detecting cars. Cars that are entering the queue for drive-through, cars that are parking in the car park. By detecting cars, they're able to estimate what is going to be the likely demand within the next 30 minutes for food within the restaurant. So we have a filter that is built to be able to detect cars. It uses something called the model. The model has been created and trained to be able to detect cars and identify those. Once it's identified a car within a video, a frame, it passes it to the next stage. This is called WebViz. WebViz as a filter is just really a way to display the new annotated video. The video has been annotated by detecting a car, placing a boundary box around it or identifying, labeling it in some way, and then displaying this newly annotated video perhaps on a browser, on a manager's workstation within the restaurant or in HQ that's able to see, we have this number of cars coming in, expect this throughput. And the great thing is, on the output of this, we can also generate report data. So we can identify what are the peak times we see cars coming through? How long are cars waiting in line? How quickly are they being processed? What's the average duration of cars in the car park outside of a restaurant? All of that helps better improve quality, better improve operations. So all of these pieces, the first filter that's ingesting the video, the second filter that is processing, the third that is displaying the output. All of these go to form what we call the VizOps pipeline. The pipeline is an artifact in its own, so you can be able to operate on it in exactly the same way you do with other application pipelines. You can take snapshots of it. You can have version control. So as you want to be able to roll this out, remember in your environment, to be able to deploy and operate Vision AI pipelines, you need to build, deploy, operate, and scale. Plainsight gives you the environment to rapidly build. It gives you a way to be able to deploy the pipeline consistently across multiple different environments, be it edge, in cloud, or on-prem. It gives you the ability to operate the pipeline, providing operational metrics, system-level metrics, application-level metrics, the ability to snapshot, reproduce, version control your entire environment. And then scale. So with an operational dashboard that shows you all of the pipelines you have running, how they're built, made up with all of those filters. The last piece, this is one of the key aspects of VizOps, is what we call the optimization loop. The model that's detecting the cars over time can experience what we call drift. It may become less accurate at detecting cars, perhaps due to seasonal change or new styles of vehicle being driven by customers. New models become available, and so that are able to help address these problems. It may be that additional training is required. With Plainsight, we have a capability called benchmarking. This allows us to be able to compare a known good model called the ground truth with what we have in place, but also with a new model. And by running pipelines in parallel, comparing the output, we're able to determine very quickly, typically within minutes, if a new model is going to perform better than the existing model compared to the perfect working model. This allows us to continually update the car detection filter to ensure we're meeting the required levels of accuracy or ever improving them. The optimization loop is what ensures that over time, application performance increases rather than getting worse. So if you want to maximize your chances of success with Vision AI to get the actionable insights that you know you can get from the cameras operating within your business, give Plainsight.ai a try today.